Good day, everyone. Welcome in physical science. But before we start, we'll be having first our pre-test. So multiple choices, choose the letter of the best answer and write it on a separate sheet of paper. Number one, what is the equation of the reaction of iron phosphate with sodium sulfate to make iron sulfate and sodium sulfate? So we have here letter A, 2 iron phosphate plus 3 sodium sulfate. And we have iron sulfate plus 2 sodium phosphate. Letter B, we have 3 iron phosphate and 3 sodium sulfate with iron sulfate plus 3 sodium phosphate. C, we have 4 iron phosphate plus 2 sodium sulfate and iron sulfate plus 2 sodium phosphate. Letter D, 4 iron phosphate plus 2 sodium sulfate and iron sulfate plus 3 sodium phosphate. Number 2, if I perform this reaction with 25 grams of iron phosphate and an excess of sodium sulfate, how many grams of iron phosphate can make A, 33 grams, B, 44 grams, C, 55 grams, or D, 66 grams? 3. If 18.5 grams of iron phosphate are actually made when I do this reaction, what is my percent yield? A, 56%, B, 57%, C, 58%, D, 59%. 4. It is a relationship of masses of the reactants and products in a chemical reaction. A, stoichiometry, B, limiting reactants, C, percent yield, D, limiting reagents. 5. If I do this reaction with 15 grams of sodium sulfate and get a 65% yield, how many grams of sodium phosphate will I make? A, 7.48 grams, B, 8 grams, C, 9 grams, D, 10.8 grams. 6. In the equation, magnesium and oxygen gas, okay, form magnesium oxide. How many molecules of magnesium on the reactant side do we need to make our equation balance? A2, B1, C3, D4. 7. Use of the following balance equation. 2C2H6 plus 7O2, an arrow. 8 here stands for arrow. Okay, going to the right? So 4CO2 plus 6H2O. If 15 grams of C2H6 react with 45 grams of oxygen gas, how many grams of water will be produced? A, 27 grams of water, B, 28 grams of water, C, 22 grams of water, D, 23 grams of water. 8. What is the limiting reactant? A, oxygen gas, B, C2H6, C, water, D, carbon dioxide. 9. What is the excess reactant? A, oxygen gas, B, C2H6, C, H2O, D, carbon dioxide. 10. Consider the following reactions: 2Al plus 6HBr. Then A here stands for the arrow going to the right. So 2AlBr3 plus 3H2 when 86.9 grams of aluminum reacts with 401 grams of hydrogen bromide. How many hydrogen gas are formed? A, 5.01 grams, B, 7.01 grams, C, 8.01 grams, D, 10.01 grams. 11. What is the limiting reactant? A, aluminum, B, aluminum bromide, C, hydrogen bromide, D, hydrogen gas. 12. For the excess reactants, how many grams are left over at the end of the reaction? A, 47.4 grams, B, 42.3 grams, C, 44.3 grams, D, 48.4 grams. 13. The reactant which was not used up after the completion of the chemical reaction. A, reactants, B, limiting reagents, C, solute, D, excess reagents. 14. It deals with a process that involves rearrangement of molecule or ionic structure of a substance to form a new substance or product. A. Chemical equilibrium. B. Chemical kinetics. C. Chemical reaction. D. Stoichiometry. 15. Which of the following is the correct sequence of chemical reaction? A. Reactant, then product. Letter B. Catalyst, then going to the right, the arrow, and product. C. Reactants plus product. D. Product plus reactant. And for our answer, so number one is A, 2A, 3A, 4A, 5A, 6A, 7C, 8A, 9B, 10A, 11C, 12B, 13D, 14C, and 15A. Now, our topic for today is limiting reactants and the amount of products formed. For our objectives, after going through this lesson, you are expected to 1. Use stoichiometry calculation to determine excess and limiting reactants in a chemical reaction. Explain why. 2. Calculate theoretical yields of products formed in reactions that involve limiting reagents. Chemical equations give the ideal stoichiometric relationship of reactants and products. However, sometimes the amount of reactants used are not mixed in the exact or proper ratio. Thus, some reactants will be excess and others will be completely used up. In a chemical reaction, reactants that are not used up when the reaction is finished are called excess reagents. So the reagent that is completely used up in this called limiting reagent because it is quantity limits the amount of products formed. Now here, for the chemical reaction, we have reactants and we have products. So we have here, for our reactants, we have hydrogen. Okay, so we have two hydrogen here, plus oxygen gas. So, and this is our product. If we combine hydrogen and oxygen gas, then it will form water in a liquid form. And this is what we call the products. So in our left side, this is our reactants, and here is our products. Chemical reaction deals with a process that involves rearrangement of the molecule or ionic structure of a substance as opposed to a change in a physical form or nuclear reaction. A chemical equation shows that the starting compound or compounds are reactants on the left and the final compounds, the products on the right, separated by an arrow. In a balanced chemical equation, the numbers of atoms of each element and the total charge are the same on both sides on the equation. For example, the figure shows the combustion of methane. So we have hydrocarbon that produces carbon dioxide and water. So like for example, here we have methane plus 2 of oxygen gas. If we are going to combine this, then it will react. So it will produce carbon dioxide and 2 molecules of water. For our key terms, what is stoichiometry? It's a branch of chemistry that establishes mole and mass relationship between reactants and products in a chemical reaction to determine desired quantitative data. Excess reagent is a reactant that is not used up when the reaction is finished, and limiting reagent is a reagent that is completely used up in a chemical reaction. In this activity, you will be introduced to simple stoichiometry. Our stoichiometry includes calculations that allow us to find the amounts of chemical involved in each reaction. So we have problem solving tip here. So the first and most important step for stoichiometric calculation is to start with a balance equation. So since our calculation use ratios based on the stoichiometric coefficients, our answers will be incorrect if the stoichiometric coefficients are not right. Here are the steps on how to balance a chemical reaction. 1. Write down your given equation. For example, we have given equation of C3H8 plus O2, okay, with the arrow here, separated with the arrow. So we have H2O plus carbon dioxide. So we have here our reactants, and this is our products. This reaction occurs when propane, we have C3H8, is burned in the presence of oxygen to produce water and carbon dioxide. Number 2, write down the number of atoms per element. So do this for each side of the equation. Look at the subscript next to each atom to find the number of atoms in the equation. So when writing it out, it's a good idea to connect. So we have carbon, oxygen, hydrogen. So we have carbon, hydrogen, and oxygen. So we have hydrogen, oxygen, and carbon. So we have three elements. So we're going to write all the elements, okay, in the equations. And then just write the word reactant and product. So here for the carbon, how many, okay, carbon do we have in their given equation? So we have three in the reactant, so just write three. Oxygen, we have here two, and just write two. Hydrogen, eight, just write eight. For the product, so we have carbon, one only, so just write one. And for the oxygen, we have one plus two, so therefore three in total. So for the hydrogen, we have two, so just write two. Now, take a look if it's balanced or not. So how many carbon do we have? Three and one, so it's not. Okay, for our next step, start with a single element. So if you have more than one element left to balance, select the element that appears in only a single molecule of reactants, and it's only a single molecule of products. So this means that you will need to balance the carbon atoms first. So we have here, we have carbon 3 and we have carbon 1. For step 4, use a coefficient to balance a single carbon atom. Add a coefficient to the single carbon atom on the right of the equation to balance it with the three carbon atoms on the left of the equation. So we have here, okay, I the coefficient 3 is in front of the carbon. On the right side indicates three carbon atoms, just as the subscript on the left side indicates three carbon atoms. So therefore, if you're going to put 3 here as our coefficient, so how many carbon do we have? It's 3. So therefore, in the reactants, we have carbon 3. So that's equal already. Next, okay, for our oxygen, so therefore we have here 2 times 3, that will be 6, right? So 6 and plus 1 here, so that would be 7. So 8 here, okay? 8 here is not included, okay? Please erase this one or delete. So only one oxygen here plus 6, so we have 7. And in our left side, we have only 2. Now, we have here number 6, balance the hydrogen atoms. Next, since you have balanced all atoms besides the hydrogen and oxygen, you can address the hydrogen atoms. So you have 8 on the left side, so you will need 8 on the right side. So use coefficient to achieve, okay, this. So on the right side, you will add 4 as the coefficient because the subscript showed that you already had 2 oxygen atoms or hydrogen atoms. When to multiply the coefficient 4 times by the subscript 2, you will end up with 8. So the other 6 atoms of oxygen come from, we have here 3 carbon dioxide, so 3 times 2 is equals to 6 atoms of oxygen plus the other 4 is equals to 10. So let us check here. So we have oxygen in our reactants, in our products rather. So we have here, so 2 times 3 again, so we have 6. Then we have 1 oxygen, so delete 8 here. 8 is not included, so it's only 1 oxygen. So 1 times 4, that would be 4, plus 6, that would be 10. So for our hydrogen, we have 2 times 4, and this is 8. So we are already equal, okay, for the products and the reactants. So the reactants hydrogen is 8, and the reactants, the products, okay, hydrogen is 8. So we have carbon 3, hydrogen 8, and hydrogen 8. So we have remaining here oxygen. So in the products, our oxygen here is 10. So we have 2 here. What we're gonna do is to put a coefficient for our step 7, balance the oxygen atoms. Remember to account for the coefficients that you have used to balance out the other atoms. Because you've added coefficients to the molecules on the right side of the equations, the number of oxygen atoms has changed. You now have 4 oxygen atoms in the water molecules and 6 oxygen atoms in the carbon dioxide molecules. That makes a total of 10 oxygen atoms and a coefficient of 5 to the oxygen molecule on the left side of the equation. you now have 10 oxygen atoms on each side. So we're going to put coefficient of 5. So we have 2 times 5 is 10. So in our reactants, the oxygen is 10, and in our products, the oxygen is 10. So let us check. So we have carbon 3, carbon 3. Okay, carbon 1 times 3, that would be 3. Of hydrogen, we have here hydrogen 8. We have hydrogen, so we have 2 times 4 is 8. And for our oxygen, in the reactants, we have 2 times 5 is 10. And here we have 1 times 4 is 4, and 2 times 3 is 6, so therefore 4 plus 6 is 10, so it's balanced. Now our equation should be C3H8 plus 5O2, then with an arrow, 4H2O plus 3 CO2. Another sample, we have aluminum plus oxygen gas reacts with aluminum oxide. So we have here aluminum is 1, so just write 1, oxygen gas is 2, and for the products, you have aluminum is 2 and oxygen is 3. So in this case, aluminum 1, aluminum 2, it's not balanced. So what we're going to do is to balance. So here, I put 4, okay, I put 4 coefficient here. So therefore, we have 4 molecules of aluminum. So we have aluminum is equals to 4. And since we have aluminum here 2, then I put coefficient 2 here. So therefore, 2 times 2 is 4. So it's balanced. And then I put here 3. So we have 2 times 3 is 6 for the oxygen for the reactants in the left side. And we have 3 times 2, that would be 6. So AL, or aluminum 4 for the reactants, and for the products is also 4, equal oxygen is 6, and oxygen is 6. So it's equal. So the equation that we are going to use is this. So we have 4 aluminum plus 3 oxygen gas and 2 aluminum and O3. Another sample of K plus CaCl2, then with an arrow reacts with KCl plus Ca. Okay, the answer would be is, so we have 2 potassium plus CaCl2. We have 2 KCl plus Ca. Okay, the L here is a small error, not big error. So let us check. So potassium is 2, potassium is 2, calcium is 1, calcium is 1. We have chlorine 2 and chlorine 2. So it's equal. Another one is, okay, here potassium plus water then reacts with potassium oxide hydroxide plus hydrogen gas. So what do you think is the balance equation of this? Okay, the answer is we have 2 potassium plus 2 water and 2 potassium hydroxide plus hydrogen gas. So we have here 2 for potassium and 2 for potassium, and 4 for hydrogen. We have hydrogen is 1 times 2 is 2, and we have 2 here. So 2 plus 2 is 4. And for oxygen is 2. So 1 times 2 is 2. So we have 1 times 2 is 2. So it's equal. Another sample, we have zinc plus iron sulfate, okay, reacts with zinc sulfate plus iron. So what do you think is the balance equations of this sample problem? Now for the answer is, so we have 3 zinc plus iron sulfate and 3 zinc sulfate plus 2 iron. So let us check how many zinc do we have here is 3. How many zinc is 3? Okay, iron is 2. We have iron is 2. We have sulfur, 3 times 1 is 3. We have sulfur here, 1 times 3 is 3. And we have oxygen, so 3 times 4 is 12. So oxygen is 4 times 3 is 12. So it's balanced. Stoichiometry is a relationship of the masses of the reactants and products in a chemical reactions. For a given mass of the substance under reaction, the mass of any other substance in the reactions can be obtained by using the coefficients of the balanced chemical equation and the molar masses of the substance involved. The amounts obtainable from a balanced equation are called symmetric amounts. The law of conservation of mass, that is, the sum of the masses of the reactants is equal to the sum of the masses of the products, can be used in checking the values of the masses obtained. Now, for example, we have here barium hydroxide plus aluminum nitrate and barium nitrate plus aluminum hydroxide. So we have here for letter A, how many grams of BaOH2 are needed to produce 20 grams of AlOH3. So letter B, how many moles of barium hydroxide will produce by 5 moles of aluminum hydroxide. So letter C, how many grams of barium hydroxide will react completely with a 1.20 moles of aluminum nitrate. Solution. So we have here, we're going to this to balance first the equation. So I write here Okay, 3. So we have barium 3 and we have barium 3. Okay, oxygen. So we have here. So oxygen, we have 2 times 3 is 6 plus 3 times 3. That would be 9. 9 times 2, that would be 18. 18 plus 6, that would be 24. So let's see here. So for the oxygen, we have 6 and times 3, that would be 18. And we have 3 times 2 is 6, that would be 24. So it's balanced. For letter A, how many grams of barium hydroxide are needed to produce 20 grams of aluminum hydroxide? So we have here the equations. So here, so barium is equals to, okay, 1 barium. So we have 137. So that would be is equals to 137. And for the oxygen, so we have here 2. So therefore we have 16. So that would be 32. And for the hydrogen is also 2. That would be 1. So 2 times 1 is 2. And we have for aluminum here. So we have only one aluminum. So therefore we have 1 and 27. That would be 27. So 0. So we have 3. Okay. So we have 3 here. Okay, times 16, that will be 48. And we have hydrogen, that will be 3. And times 1 is equals to 3. All right, so we have the molar mass of barium hydroxide, so is equals to 171 grams per mole. So where did we get it? So 137 plus 30 plus 2, that will be 171. Another one is molar mass of aluminum hydroxide. So here, the first one is here, and the second one is here. So therefore, we have 78 grams per mole, 27 plus 48 plus 3. That would be the total, 78 grams per mole. So already get the molar mass of barium hydroxide and aluminum hydroxide. So we have here and we have here. So let's continue. Okay, so mass of barium hydroxide, the first one, so 20 grams of aluminum hydroxide. So here in the given problem, so 20 of aluminum hydroxide times 1 mole of aluminum hydroxide over 78 grams of aluminum hydroxide, where it gets 1. So the molar mass of aluminum hydroxide multiplied to 3 moles of barium hydroxide over 2 moles of aluminum hydroxide. So where did we get this? Okay, from the coefficient here. All right, so here, just write 3. Another one here is 2, just write 2 times 171 grams of barium hydroxide. Where do you get this one? So the molar mass of barium hydroxide over 1 mole of barium hydroxide. So we're going to cancel the units. So cancel the cancel, cancel, cancel. So if cancel cancels, the remainder is grams of barium hydroxide. So here, how many grams of barium hydroxide? So the remainder is grams of barium hydroxide. So next, 20 grams times 1 over 78 grams times 3 over 2 times 171 over 1. So the answer will be 65.8 grams. Therefore, the mass of barium hydroxide in a given problem is 65.8 grams. Next, how many moles of barium hydroxide were produced by 5 moles of aluminum hydroxide? So number of moles of barium hydroxide is equals to 5 moles of aluminum hydroxide times 3 mole of barium hydroxide over 2 moles of aluminum hydroxide. So where they get to is 1 in the mole, okay, coefficient. So we have 5 times 3 over 2, that would be 7.5. So the number of moles of barium hydroxide is 7.50. Cancelled, cancelled. So the remainder is mole of barium hydroxide. Letter C, how many grams of barium hydroxide will react completely with 1.20 moles of aluminum nitrate? So we have number of moles of barium hydroxide with 1.20 mole of aluminum nitrate times 3 moles of barium hydroxide over 2 moles of aluminum nitrate. So whether it gets 1, this is from the coefficients of the equation. So times 171 of grams of barium hydroxide over 1 mole of barium hydroxide. So cancel, 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 cancel. The main unit is, okay, number of moles of barium hydroxide. Now for additional activity, ammonia gas. So we have can be produced by reacting nitrogen gas and hydrogen gas if 5 grams of nitrogen is to be used in the reaction. So find A, the mass of the hydrogen by reacting nitrogen gas and hydrogen gas. If 5 nitrogen gas, letter B, the amount of ammonia gas that will be produced. So this is for your assignment. So, next OL, we are going to check this. Okay, that's it for today, and God bless us all.